Good morning, seventh grade. We spent last week, or actually the last couple of weeks, talking about equations. The next couple of weeks, we're going to talk a little bit about what are called inequalities. For while it's actually often important to know the answer to something, a real truth of mathematics is that sometimes you don't always just need the exact answer. For example, these two images there. I'm not necessarily, if I'm driving home from school, I'm not necessarily satisfied with just having just enough gas to get me home, because that would mean I would, run out of gas in my driveway. And likewise, if you remember going to an amusement park or a carnival, maybe when you were a little bit younger, and you didn't reach that certain line, you might have been disappointed. But does that mean you have to be exactly that tall to ride that line? I mean, it says you must be this tall to ride. I mean, right there, it says a sign says that right there, you must be this tall. So doesn't that mean only people that height get to actually ride that line? Probably not. But it means it's that tall or bigger. Okay, it's an inequality. If you're going out to buy something, you don't necessarily bring the exact amount of cash you need, or you don't make sure you have the exact amount of cash available in your bank account if you're using like a debit card. You want to make sure you have at least enough or more. Okay, so those are inequalities. There's lots of inequalities that we experience every day in sports. Okay, you don't necessarily want to score a certain amount more. You just want to score more than the other team, unless you're golfing, in which case you want to score less. Okay, so those are all examples of inequalities. I'm going to put a couple up now. Here's two examples. One that offers free admission for kids 12 and under at San Diego museums, and the other that offers free kids meals for children under 12. And I just want you to take a moment, pause the video if you need to, and think about the difference between these two offers. Not that one's food and one's museums, but in relation to a 12-year-old. Think about the difference between the two. So you probably realize that in the first one, it's kids 12 and under. If you're 12, you get free admission to that San Diego museum. But if you're 12 and you're not pretending to be under 12, you don't get that free meal, because a free meal is under 12. And that's why there's a difference between inequalities. In fact, there are 5 basic inequality symbols. Okay, you're familiar with them before. The most common are the greater than and the less than signs. Okay, and it's important to actually know the difference between the two. The one on the left, this one here, is the greater than sign. So you might read one value is greater than another value. This one here is the less than sign. One value is less than another value. An easy way to remember which is the greater than or the less than sign. The less than sign, not quite because it's angled, but it's sort of like the letter L. It sort of opens on the same side as the letter L. So that's the less than. So the meal is an example of a less than. You can get a free meal. We'll call the meal M. If you're less than 12. Okay, that's a free meal. Okay, now the other two are inequalities, and I shouldn't say the other two, there's actually a third one, is greater than or equal to, or less than or equal to. And this is an example of what you get at the museum. You can get an admission to the museum, so you get a free admission, if you're less than or equal to 12. Okay, so there's a slight difference between the two. On the museum one, you could be 12 or you can be less than 12. One for the free meal, you need to be less than 12. I mentioned there was one more inequality sign. There is. It's a very simple one. It's that. It's called not equal to. Really doesn't get used a whole lot because it doesn't tell you much other than that two things are not equal, which often is pretty obvious. So those are the 4 inequality signs, however, that we're really going to be focusing on. So let me clear my screen, go to the next page. Okay, so is it possible then to list every possible value that solves an inequality? Okay. Can you tell me every age for which somebody would get a discount? Okay. No, you probably couldn't. I guess yes. You could say at some point is a realistic as are you really going to have an age of 214? Probably not. I don't think anybody's ever lived that old. I mean, you could look up what's the oldest person ever lived, and maybe stop at that. But if I just had an inequality and just said it was 50 or more, you couldn't list everything. In fact, it doesn't specify that it has to be a whole number. It could be 50.1 years old, or 50.11 years old, or 50.111 years old. And when you start having decimals, you can't list everything. Okay? So in equality, you can't necessarily list all the possible values. So we have a way to show that. And the way we show all the possible values that solve an inequality is often through a graph. Okay, very simple way to do it. We're going to look at a couple, and I should mention that this is actually going to be the same video for Monday and Tuesday, because we're basically going to be doing two sides of the same coin. If we've been meeting in school, we would be doing this in one day. We'd have an hour to talk about it. We'd have time to do homework because we only have about a 10 to 15 minute video and then 30 minutes to work or so. We're not going to have a whole lot of time to do that. So I'm splitting this up into two lessons, but it's just going to be this one video. So if we think about the inequality, people 50 and over. So we want people who are greater than or equal to 50. Okay, that's 50 and over. The people are 50 or more. Okay, so how we show that on a number line is we find where 50 would be. And I don't care, you don't put in numbers in the rest, and actually it's going to be on IXL, so you don't have to worry about that. And we mark a point at 50. Okay? And the way we mark a point at 50 is we put a dot there. Since you can be 50, and I'll show you the difference, we put a solid dot on 50. And then we simply shade in everything to the right like that. That graph right there, that image shows me 50 years old or older than 50. Okay? So if that's 50 and plus, and actually now I'm looking at it, I guess 50 plus means 50 or over. But let's think about the two examples with the meals for a moment. I think the next page here is going to be a blank page. So yeah, so it's relatively blank. So let me clear the slides. So let's think about those two examples. The San Diego museums, you got a free admission if you were less than or equal to 12. Okay, you've got a discounted meal if you were less than 12. Okay, so let's just graph these two inequalities. So if you're less than or equal to 12, that means you can be 12, so we put a solid dot on 12. Now, where's less than 12? Well, less than 12 is 12 that. Okay. Now, again, in context of the problem, none of this makes sense because you can't have a negative age. But just in terms of that inequality, it solves that. In math, we actually call that an extraneous solution. Now, this one's a little bit different because you can't be 12. So the challenge is, well, what's the first number less than 12? Well, the reality is you can't tell me the first number less than 12. You might have been thinking 11, but what about 11.5? 11.6 or 11.9 or 11.99 or 11.999. Okay, if you're thinking 11 point and then an infinite number of nines, that's 12. If you're thinking one less than an infinite number of nines after the decimal, well, how many is that? Okay, so when we show that, we still compare it to 12, except on 12, we put an open dot. It says we're comparing it to 12, but 12 is not part of the solution. and then we shade in like that. So Monday's homework is simply going to be this. You're going to be given an inequality, and you're told to come up with a graph. I'll show you how to do that on IXL in a moment. Okay, you're going to be given the inequality, and you have to come up with a graph. Tuesday's assignment, you're going to have the graph, and you have to write the inequality. Okay, so remember, you're always comparing it to a certain point. You have to determine whether the dot is solid, which means if the value is included, the dot's solid. If the value is not included, the dot's open. And then which side is shaded. So let's pull up those 2 pages on IXL. Let's look at a couple of problems. And then that'll be it. And I'll post this video both on Monday and Tuesday. If you watch it all on Monday and you feel comfortable with this, don't worry about watching it tomorrow. Just go to the assignment. Otherwise, if you want a little bit of refresher, feel free to watch it both days. So here's what we're going to do on Monday. Okay. And this is graphing. Okay. You're graphing the inequality on the number line. Okay, so graph x is less than 10. It says to draw a plot and endpoint, select an arrow. Select an endpoint to change it from closed to open. So we're comparing it to 10. So we're going to put a dot on 10. I can click that to determine whether it's an open dot or solid dot. Since it's less than 10, it can't be equal to 10, so that's going to be an open dot. Okay. Okay, so that's the dot. And then I can drag it one way or the other to say which way. Now, I'm going to drag it all the way to the endpoint because any number to that side is less than 10. And I'm going to hit submit. And looks, I get that wonderful positive reinforcement. Okay, numbers less than 2. Again, there's 2. It's less than 2. It's not equal to 2, so it's going to be an open dot. And submit. Okay, so I'm going to jump to the next level. Oh, they make it harder by making the numbers a little bit bigger. Okay, so 900. Less than 900 open dot. Less than 900 over there. Let's get a one that's, okay, now greater than or equal to 200. Here's 200. It's greater than or equal to 200, so that's my solid dot because 200 is included as part of the solution. There. And I believe you do need to drag. Let's see what happens if you don't drag it all the way to the end. X is greater than 0. So think about what kind of dot would be on 0. That's correct. It's an open dot. And let's say I only went that far. No, it's going to tell me. And again, take a moment to look if you get something wrong and do it. Okay, I got it. I understand what I did because we did it intentionally. 72, they start giving you numbers that are not even whole numbers. You know, challenge zone, let's see what a challenge problem looks like. Oh, less than or equal to 930. Oh, you have to find 930 on the number line. There's 930. You have to determine, is it going to be solid or dotted? Well, because it's less than or equal to, it's going to be solid. And which way are numbers less than 930? I think it would be that way. So that's Monday's assignment. That should not take you long, even with negatives. Now, just be careful about negatives. Okay, be careful about negatives because, for example, there's 121, open dot. Greater than 121 is this way. Please remember that. Negative 120, negative 119 are larger numbers than 121. So that's Monday's assignment. Tuesday's assignment, basically the other side of the same coin. Tuesday's assignment, you're given the graph and you need to write the inequality. So you start, for example, with the variable. So x. So there, and I'm comparing x if you want to. I'm comparing x to 4. Okay? Now I got to decide what inequality goes in between the x and 4. Well, since 4 is not included, it's going to be greater than or less than. Well, all these numbers here are greater than 4. So I want x is greater than 4. This graph shows me all the numbers that are greater than 4. Okay. Now this graph Shows me numbers that are greater than 7, but also equal to 7. Again, there's that closed dot. So x is greater than or equal to 7. Okay. This one looks like, let's see, it showed me values less than or equal to 3. Okay. X is less than, nope. I can actually choose, actually, if I do that, I'll just type it in. I'm trying to see, no. Less than or equal to 3. I just want to see what would happen if I type it in. Let me see what happens if I just type it in, because I'm used to doing that. Nope, it doesn't take it. So you make sure you click on that little button on the bottom. Okay, this is just numbers less than 4. Let's jump a level. Oh, let's just jump a couple levels. Okay. So, again, on the left-hand side, if it's the left-hand side of the number line, they were talking about numbers less than a certain value. So we're talking x is less than -131. Please make sure you type it in correctly. This should be a relatively quick assignment both days. I don't want you getting a bunch wrong because you just typed in something a little carelessly. All that. And let's just jump to the final level and just see how that works. Oh, boy. This looks so much harder than the last problem. Note the sarcasm? I know. Okay, so x is greater than -8. So that's going to be it. Again, this should be a relatively straightforward problem. I mean, if you want to do both T2 and T3 in one day, go ahead, because this is going to be Tuesday's homework. You could get it both done in one day, and then Tuesday you'll have a day off for math. Okay, I will see you on Thursday. If not, just do one on Tuesday, one day, one on Tuesday. And if you all do it this way, I don't have to email anybody on Wednesday saying, oh, you're missing some assignments. I'll see you on Thursday. And so have a good couple of days. And I'll see you Thursday in person. And then Friday will be another lesson posted. Okay, that's all. So long.